Let's do another example of genetic algorithm study. Suppose it is desired to find the maximum value of peak function of two variables. For example, we have a function like this. This is the compacted form. In fact, this function we have applied u to do the grade descent measure to try, where parameter s and y vary between -3 to 3. But this is not an integer, or not an integer. That can be the real value in this range. The first step is to represent the problem variable as a chromosome. So parameter s and y as a concatenated binary strings. For example, like here, that we use a 8 bit for s and 8 bit for y to do the encoding. Because the 8 bit still have a range, his range for s and y is from n9 h0 or h0. His range is from h0 to the 1 1 1 1 1 1 1 1. So that the change range is from h0 to h1. So we choose the size of chromosome population, for instance 6, and randomly generate initial population like the same. The number of chromosomes is 6. The next step is to calculate the fitness of each chromosome. This is done in 2 stages. First, a chromosome that is a string of the 16 bit that can be partitioned into 8 bit, 2 8 bit. Here is another 8 bit. And then based on the string are converted from binary to decimal. So the same with previous problem, that this value is, for example, this is s, and this is for y. Then s value is 1 multiplied 2 7 to order 7. And then with summation we can find the value is 138 for decimal. Another value also can find, that is for y value is 59 to decimal. So we can encode the number to the binary code, and the binary code also can convert to decimal. Now the range of the integer that can be handled by 8 bit, that is from range from 0 to 2 order 8 minus 1, is mapping to the actual range parameter of s and y respectively. That is the range from -1 to plus 3, -3 to +3. So -3 decrease +3, then the value is 6. The value is 6. 6 in fact is mnemonic. 6 is the mnemonic value. That is the range of the S and Y can mapping. And then this one the value is 256 -1. So we can mapping the scaling of the SIP area mapping to the scale of 255. That each scale mapping to the integer is this value. So if we hope to find the S value, the mnemonic, then we can use this one multiply this one. This one is found from here. So we can find this value. So the same for the Y value. We can use this value to multiply this value. But here, why we need to decrease -3? We decrease -3 because this is the schedule for 6. In fact, the range, the schedule is like this, from -3 to +3. So here is 0. So if we can -3, that if on this side the value will become minus, under this side the value will become positive. That is mapping to real value. So we need to decrease 3. So using decoded value of S and Y as print in mathematical function, genetic algorithm calculated the fitness for each chromosome. To find the maxima of the peak function, we will use crossover with the probability equal to 0.7 and mutation with the probability equal to 0.001. As we mentioned earlier, a common practice in genetic algorithm is to specify the number of generations. Suppose the number of generations we set is 100. That means they will run 100 times, then stop. This is the generative algorithm. Will create 100 generations of 6 chromosomes before stopping. So after this, we can find this one. Initialize has a 6 point, and the range is from -3 to 3, and this one. So from this one we can find the map. And in fact, we want to find the maxima value. So when iteration, so here the surface of the peak function first generation, the value just became this. And then finally, the local maxima is here. The global optima is here. So this measure after iteration. For example, here, less than the 50th generation, they find the fitness value. The value of output is here, is smaller. But when the generation continue to do the search, we can find they find this solution. This solution is better. And then after the 19, they became this one. This one is better than this one because we want to find the maximum value. And both of these node is on our solutions. Okay, this is about another application of the genetic algorithm that we can find the running result. The running result after 100 generations. So this is for more chromosome we generate in 20 generations. So before introduce about that case, we also introduce another evolutionary computation strategy. That is an evolution strategy. Evolution strategy is another approach to simulate the natural environment that was proposed in Germany in the early 1960s. Unlike genetic algorithm, this approach is called an evolutionary strategy that designed to solve technical optimization problems. In 1963, two students that on the Technical University of Berlin, that is Ingo and Hans Paul, will work on the search for optimal shape of bodies in a floor. They decide to try random changes in the parameter define the shape following the example of natural mutation. As a result, the evolution strategy was born. Evolution strategy was developed as an alternative to engineer institution. Unlike a genetic algorithm, evolution strategy use only a mutation operation. So they are more easy. They just randomly to change the parameter value and put the parameter value to the evaluated function to find the fitness. If the fitness became better, then replace this parameter and then repeatedly to run and to find the best parameter of the function to solve the question. So the best evolution strategy in it is simplest form that termed as 1+1 evolution strategy. One parent generates one offspring per generation by applying normally distribution mutation. The 1+1 evolution strategy can be implemented as follows. That the first step, choose the number of parameters n to represent the problem, and then determine a feasible range for each parameters. define a standard deviation for each parameter and the function to optimize. So in this formula, we can find that for S1 parameter, that we define his minima value and maxima value. For S2 parameter, we also define his minima and maxima value. And then until all the parameter, the Sn. So this is a range. This is a range. So the S1 will locate in this range, and will randomly select in the for operation. So randomly select an initial value for each parameter from the respective feasible range. This set of these parameters will be constituted the individual population of parent parameters S1 to Sn, and then calculate the solution associated with the parent parameters. Then big S equal to F, and then we apply the randomly select the value to this parameter, try to find S value. So create a new offspring parameter by adding a normally distributed random variable A that with a mean 0 and prescale deviation theta to each parent parameter. So here this is a normal distribution that with mean is 0 and deviation is theta. Normally distribution mutation with mean 0 reflect the natural process of evolution. Smaller changes occur more frequently than large ones. And then calculate the solution associated with the offspring parameter. This is offspring parameter. We add Si prime, and here we can get a new value, big S prime. And then compare the solution associated with the offspring parameter with the one associated with parent parameter. If the solution, this is important part, if the solution for the offspring is better than that for parent, replace the parent population with offspring population. Otherwise, keep the parent parameter, and then repeat, go to step 4, and repeat process until a satisfactory solution is reached, or a specified number of generations is conceded. So, an evolution strategy reflects the nature of the chromosome. A single gene may simultaneously affect several characteristics of the living organism. On the other hand, a single characteristic of an individual may be determined by the simultaneous interaction of several genes. The natural selection acts on a collection of genes, not on a single gene in isolated. Okay, let's do another case. This is about the maintenance scheduling. Maintenance scheduling problems are usually solved use a combination of the search technical and heuristic. These problems are complex and difficult to solve. They are NP-complete and cannot be solved by the combination of such techniques. Scheduling involves computation for limit resource and is completed by a great number of the badly formalized constraints. So the step in genetic algorithm development. The first step is specify the problem, define the constraint and optimal criteria. The second one is represent the problem as a chromosome. And the third is to define a fitness function to evaluate the chromosome performance. The fourth is construct the genetic operators and then run the genetic algorithm and tune its parameter. Okay, on this part, we continue the case study. Okay, we look this case study about the power company maintenance problem. This is a schedule of 7 units in 4 equal intervals. The problem constraint is like this. The maximum load is paid during 4 intervals is 18, 19, 65, and 70 MW. MW is minimum power for working. Maintenance of any units start at the beginning and interval and finish at the end of the same or adjusted interval. The maintenance cannot be aborted or finished early than scheduled. The net result of the power system must greater or equal to 0 at any interval. So the optimal partition is the maximum of the net result at any maintained periods. This is the problem of the question. 4 interval and 7 unit, and for each interval we hope have the maximum load is paid, and then 7 unit has his limit of power supply. So we look this unit data and maintain requirement. For example, we have a 7 unit. Every unit, in fact, is a working power machine. The unit 1, his unit capacity, that MW is 20, and number of intervals required for unit maintained is 2 seasons, because 1 year have 4 seasons. That means this machine need to have 2 seasons for maintain. And unit number 2, his unit capacity is 15. And then they also need to have 2 units to do the maintain. And the other the same. For example, the 6th, that his unit capacity is 15. He need one interval to do the machine maintain. We look at this example. For example, in Unit 1, we do an example for this. Unit 1 have 3 different type of sedation. So we just select one of condition here. So Unit 1 is placed here. Unit 2, we also select one of condition to become a chromosome. They select this one, 0011. Unit 3, we also select 4 of condition here. The system select is this one. And the same, Unit 4, select is this one. Unit 5, select is this one. And Unit 6, select is this one. And Unit 7, sedation is this one. So this combination became the chromosome. So if we generate 6 chromosomes, that is the combination of the 7 units. Okay? So for example, the crossover operation in here, we also can do the change. We select cross point here, and then we do the change. All this move up, and all this move down. So became this one. That is a crossover operator. And for the mutation operator, it's a little different. We use interval as the unit. So the mutation unit is use the interval. This interval, or this unit. So for example, mutation, the unit 3 mutation can be this one to this one, but they cannot be double one on this area. So the mutation is just to look the table that, and then they do the crossover operation. The crossover that need to follow and mapping to the location. Just change, or just do the change. And the mutation in fact, they need to look at the table. For example, this is unit 3. This unit 1, unit 2, unit 3. When unit 3 to do the mutation, they only can select the unit 3 possible combination. So they select this one. Is do the table. Now which unit will replace with current one. So based on this, the performance graphing and the best maintained schedule create in a population of 20 chromosomes. So the red line is the best. And our program can run based on this, that with 20 chromosomes. That each node have one output, and one output have a combination. For example, that the time interval is on the first interval unit 4 and unit 5 to do the maintain. On the second interval unit 2 and unit 7 to maintain. On third interval unit 2, unit 1 and unit 6 to do the maintain. And the interval 4, unit 1 and unit 3 to do the maintain. And then, because our schedule is like this, so we can calculation and summarize for example, on the first interval, the output of the power, for example, unit 4 and unit 5 in this area, and unit 5. So the power here is 14 at 15. We can find this value of 14 at 15 and to find the output of the power. And then we also like this and summation. That interval, the maximum output power is the limit condition. So another one like this for the 20 chromosome, that best maintained schedule creating in a population of 20 chromosomes. So we have a different schedule. Example, and then we do an example how the calculation. For example, here that in this schedule in this time schedule have a unit 1, unit 6, and unit 7 to do the maintain. So unit 1 is 200. And unit 6 is here, is 15. And unit 7 here is 10. So the median is the totally have 45 mega working power need to shut down. But that means still have some power plant, some power machine can to continue to work. So this one is unmaintained on unit 1. This one is unmaintained. And 7 is unmaintained. So the remainder is 15. And add 35. And then we add 40. And then add 15. So the summation is 101. So mega working power. This value, because our question as previous that in every interval they have a constraint at least how many power need to supply. So this value needs greater than this value need greater than this one. I think here maybe the first interval is 85. 85 or not. Look the schedule similar. So 105 are greater than 85. So the situation is good. So our algorithm today is better. That means that we can have more power to supply in each interval that the company can set to operations. Okay. Okay, this is about the scheduling problem that we can find on this problem that the genetic algorithms are applied to different way because the encoding method that is different. So different problem we have a different encoding method to solve it. But I will give example is also not the only one to do the genetic algorithm because genetic algorithm is based on your chromosome encoding. That is the most important part. Okay.